Good day, I'm Dr. T and welcome to my fence. I've got a tree that I recently had to cut down. It's starting to get a little bit fungusy and it was starting to hurt things. So it was time to go, I'm afraid. But I do want to take this opportunity to look at this stump and point out a little bit of chemistry. So as chemists, one of our primary goals is to understand the world around us, understand why things do things. And so if I've got my tree over here, I could take my hatchet and I could cut on this tree, and I could do this a couple of different ways depending on where I put my chop. So if I chop like this, I can bury my hatchet fairly straightforward. It's already been cut a little bit on the earlier takes of this video, but it doesn't take that much work to go into the wood. It buries itself pretty easily. Now, that's with the grain. Let's go against the grain. Okay, letting the car pass. So I can chop into the wood. Well, I can try at least. But I'm not going to chop very far into the wood. It's going to take a lot more force. So if I want to cut this wood this way, that's not that hard. But if I'm going this way, I'm going to spend all day hacking at this tree. Needless to say, I'm not going to spend all day using this hatchet. So, why? What's up with this? Well, trees are made from wood, as you probably knew. And wood is made from two primary polymers. First is cellulose, and that creates the grain of the wood. So it's going up and down the tree. When I am swinging in this fashion, then I am splitting apart the cellulose strands. I'm breaking intermolecular forces. However, when I go this way, instead of trying to unzip them, I'm actually instead trying to break them apart and break covalent bonds, which are a much, much stronger connection. And this is, as you can expect, I only went in a few millimeters because it was able to stop me. It's a much stronger connection. Now, when it comes to the other polymer, lignin, that's going to do cross-linking, and that's going to toughen up the wood. So different trees have different amounts of lignin. Those with high amounts of lignin usually have very sturdy, strong woods. Those with low amounts of lignins usually don't. They're softer wood, although softwood versus hardwood actually is nothing to do with the wood itself, strangely enough. Okay, so with that said, it's summer in Georgia. It's hot. I'm going in.